My work just finished a resource I've been working on for over a week called RAID. Real-world AI definitions, not redundant array of inexpensive disks, which is the first thing I think of whenever I hear RAID, either that or bug killer. But yeah, real-world AI definitions. And I'm actually going to go into it and talk about it. So I'm going to go ahead and jump in here. Okay, so I see a lot of definitions for different AI terms out there, and I want to put my own thoughts into a long form version. And that's basically why I did this. And it's mostly for me because I love this quote. I forget the name of the woman. I need to memorize that. But she basically says, if you are thinking without writing, you only think that you're thinking. And I think that is such a powerful statement because when you are writing, and this is why I call this a Feynman approach to learning. It's basically, Feynman said, if you think you know something, try to teach it. And you will figure out pretty quickly that you probably don't know it as well as you thought you did. And I've always known this for a very long time. So starting back in 1999, I started writing tutorials to myself to explain things. So when I was learning tech, I literally would try to learn the tech from textbooks, and then it wouldn't make sense to me, so I would go write my own explanation, and then I would just use that whenever I wanted to remember something. And that turned into my tutorials page, which is how I got started on the internet. So table of contents here, the expanded definitions table, the one-liner definitions table, and then I break out AGI and ASI into two different sections. So we're going to start with the one-liner AI definitions table, and this is coming off of Hamal Hussein's AI bullshit knife, which gave violently short definitions for a bunch of AI terms, and this is my expanded version of that. Okay, so this is made to like crystallize in your brain what these things are in very, very crisp conversational form. And we're going to go into more detail in the further ones. But AI, tech that does cognitive tasks that only humans could do before. And the reason I have that only humans could do before is because that's a moving bar. So before there was a chess playing robot or a chess playing AI, everyone said, well, yeah, but it can't play chess. It never will be able to play chess because that's a human thing. And of course, you can do that now. Image generation used to be, image identification, being able to tell the difference between a dog and a cat. That was a very, very hard problem for a very long time. You have to think in terms of like what currently is a thing that only humans can do that AI cannot do yet. That is the barrier which determines AI or not. Because the moment you cross over into that and AI suddenly becomes available to do that, that's what's currently called AI. Now, what's interesting is as it moves further and further out, people forget that that's AI, like image recognition. A lot of people are like, that's not AI, that's ML. Well, it's still AI. First of all, because machine learning is a subset of AI, but also because it's doing something that only humans could do before. So I love that definition. Very flexible. Machine learning, AI that can improve just by seeing more data. And we're going to talk about this more later on. Prompting, clearly articulate what you want from an AI. RAG, provide context to an AI that's too big or expensive to fit in a prompt. An agent, an AI component that does more than just LLM call to respond. So it's not just call and response. That's just regular AI. An agent does more than that, taking on more of the work. Chain of thought. Tell the AI to walk through its thinking and steps. Zero shot. Ask an AI to do something without any examples. Multi-shot. Ask an AI to do something and provide multiple examples. Prompt injection. Tricking an AI into doing something bad. Jailbreaking, bypassing security controls to get full execution ability, or at least as full as possible. Doesn't doesn't necessarily need to be full. AGI, general AI smart enough to replace an $80,000 white-collar worker. And ASI, which is superintelligence, general AI that's smarter and or more capable than any human. So I think that's a pretty clean list for thinking about these concepts. And now I want to go into more detail for each. So AI. AI is technology that does cognitive tasks or work that could previously only be done by humans. So cognitive tasks or work. And I might clean that up at some point and just make it work or cognitive tasks. Anyway, lots of different ways to define AI, so this is going to be controversial. And this is what I talked about. Well, yeah, of course, AI can do this, but it still can't do this, and it probably never will be able to. And then the narrator voice says, yeah, that happened 7 months later. And this is why I like the definition, is because it moves over time. Machine learning, a subset of AI that enables a system to learn from data alone rather than needing to be explicitly programmed. This is super exciting to me as a definition, actually as a concept. I can't believe the program is the same, but you change the data and the program gets smarter. That blows my mind. And it's like the most important. In fact, if you want to go tighter, learning from data alone, or a technology system that's able to learn from data alone. Like lots of different ways you can skin this thing. Prompt engineering. Prompt engineering is the art and science of using language, usually text, to get AI to do precisely what you want it to do. Yeah, a lot of people think prompt engineering is like this really special thing. Others think it's not important at all. I think it's absolutely an art and a science because it's more about clear thinking than about text itself. Just like writing, the best prompt engineer is the same. It comes from deeply understanding the problem and be able to break out your instructions to the AI in a very methodical and clear way. So the clearer you can think, and the clearer you can think about problems and describe methodologies, that's what's going to make you really good at prompt engineering. Don't think of it as an AI thing. Think of it as a thinking thing and a writing thing. Retrieval Augmented Generation, RAG. Retrieval Augmented Generation, RAG, is the process of taking large quantities of data, which are either too large or too expensive, to put in a prompt directly, and making that data usable as vectorized embeddings to AI at runtime. And I say it's important to understand that RAG is a hack that solves a specific problem, which is that people and companies have way too much data, gigabytes, terabytes, petabytes of data that they want their AI to be aware of when performing tasks, but AI can only handle small amounts of that data per interaction, and that's what RAG is for. So the solution we come up with is to use embeddings in vector databases to encode relevant information and send that along with the prompts. And it's not really clear what the successor is going to be, but one option is to just have massive context windows and put the raw content in there, but then you have cost problems. So you would need that to be very cheap for that to work. Agents. An AI agent is an AI component that interprets instructions and takes on more of the work in a total AI workflow than just LLM response. For example, executing functions, performing data lookups, etc., before passing on results. Yeah, so there are lots of different definitions for agent. I think the trick is to go back to the Latin, the agens or agens, which is to do or to act. So I think eventually this is going to be like an AI component that has its own mission and goals and can use its resources and capabilities to accomplish them in a self-directed way. That is the true nature of agent or agens from the Latin. But I think in this current version, I think the best way to say it is that anything that acts on behalf of the mission and something that performs multiple steps towards the final goal. And that's why I'm using this definition for agent. Chain of thought, a way of interacting with AI in which you don't just say what you want, but you give the steps that you would take to accomplish the task. So you're basically teaching it how you think, which is essentially teaching it how to think like a human. And then it uses that template to sort of do that every time it's going to solve the same type of problem. And to me, it's kind of an example of what we talked about in prompt engineering, clear thinking. It's walking the AI through how you think when you're solving a problem yourself. Prompt injection, a method of using language, usually text, to get AI to do something it's not supposed to do. And a lot of people confuse prompt injection with jailbreaking. And I think the best way to think about this, and thanks to Jason Haddix for talking through this with me, because he had a very similar definition, is to say prompt injection is a method. It's an attack avenue. It's not a payload. Whereas jailbreaking is a goal. We're trying to bypass the security on a system. Prompt injection is not bypassing the security on a system. Well, it's a method for doing that. It's a way of tricking the AI into doing something it's not supposed to do, but that could be telling a joke that it's not supposed to tell. That could be showing a picture it's not supposed to show. It doesn't mean it's bypassing the security on a system so you can execute commands. So it could be data exfil, it could be code execution, it could be image generation, it could be anything. So easiest, cleanest way, at least in my mind, to think about this, prompt injection is a method, jailbreaking is a goal. All right, we talked about jailbreaking, going to pass that one. Artificial general intelligence, the ability for an AI system, whether a model, a product, or a system, to fully do the job of an average US-based knowledge worker. In other words, it's not just competent at doing a specific thing, which is called narrow AI oftentimes, but many different things, which is why it's called general. So basically, it's some combination of sufficiently general and sufficiently competent, and the amounts of which are, going to be debated. So generally competent at many other cognitive tasks, sample efficient, so we can learn quickly from like one example or a low number of examples. And the system should be able to apply new information, concepts, and skills it learns to additional new problems. So it's not just generally intelligent from its training, but when it learns new things, it's generally intelligent at applying those new things it learned to everything else in the future. And I like this definition focusing on the worker, replacing a worker, because I think this is arguably what matters most to humans when we talk about AI discussion, which is the future of humans in a world of AI. Regular people don't care about processing speed or model size or model weights or any of that crap, right? What they care about is if and when any of this is going to actually affect them. And that means job replacement, mostly. Or at least that's the most important thing. So these are the levels that I see within that job replacement of this average white-collar worker. So first level is better, but with significant drawbacks. And I'm not going to go through all of these, but it's like the interface, the language, the confusion, the errors, flexibility. Basically, real-world work environments are kludgy and lame, and they change all the time, and it's basically a giant mess. This level 1 is basically saying, yes, we brought in an AI worker to replace that person, or we didn't hire a person, we used an AI worker instead for growth, if you want to be nice. So that's what happened. We brought in this level 1, AGI 1, and here's the problem. It's kludgy. So the problem is that they're doing the work, but you have to clean up after them. So the interface, proprietary, cumbersome. The language that you have to use, it's still kind of like AI language. It's almost like you're prompting. You're not just normally talking to them. It gets confused a decent amount of the time. There are frequent mistakes which need to be fixed by humans. And if you want to change what this thing is doing, it needs to be largely retooled. Not like in a major way, but you've got to have a conversation with it. You've got to change some documentation. You got to do some stuff. So going back to the top level of this one, better, but with significant drawbacks. So it is right at the line of being too much work and not good enough to replace a human, right? That's the trick. It's just barely better, barely. And sometimes you can't tell if it's better or not. It might be too much work. Next one, it removes a lot of those problems. So it's like in the middle. It's like decent, competent, but imperfect. So mostly normal workflows, mostly human with exceptions, doesn't get confused very often, fewer mistakes, and the mistakes aren't as bad, and adjusts decently well to new direction from leaders. So that's like the middle level. And then AGI 3 is full worker replacement. So this can replace this average 80K worker in 2022, white-collar worker in the US. It can fully replace them. So when you talk to them, you talk to them just like any other employee. You could text them, you could voice them, you could do video with them. It's just like an employee. You talk to them exactly like an employee. They're confused the same amount or less than the $80,000 employee. Keep in mind, humans have all these problems too, right? Humans also get confused and need to be retasked or whatever. So it's not like we're competing with perfection here. Same or fewer mistakes than an $80,000 employee. Employees also make mistakes. And just as flexible or more than an $80,000 employee. Employees also have trouble, like completely being retasked. It's like, I thought I was working on that. What are you doing? So this is basically saying it's just as good as them or better. So this is the top level of complete worker replacement. I think this is going to take a decent amount of time. And then the next question is like, okay, but what if it's like that, it's a full replacement for that worker. So it's AGI 3, but with an IQ of 150. Well, that's really powerful. And I'm not working on that axis. I'm only working on how good of a worker are they. And that's the 3 levels for AGI. Okay, let's do ASI, a level of general AI that's smarter and more capable than any human that's ever lived. So this is interesting for a number of reasons. One, it's a threshold that sits above AGI, and people don't really agree on that definition. And the second thing is, at least as I'm defining it, it has a massive range. And third, it blends with AGI because AGI just really means general and competent, and ASI is also general and competent. So really, ASI is also AGI. It's just at a level beyond any human. So AGI is replacement for a human worker making 80K in the US in 2022, pre-Gen AI. And ASI is more smart and more competent than any human. And the model I'm using there is like John von Neumann, because unlike Einstein and Newton, he was very broad. He was a generalist, right? So he did game theory, physics, computing, lots of other stuff. But I don't think being smarter is the only thing that matters. Because I think it comes down to multiple things. So if I look at all the different things that I'm putting into ASI, it's like your ability to model abstractions of reality at these different levels. It's the ability to take action, perceive, understand, improve, solve, create, destroy. And then it's like, okay, what fields are we innovating in? What problems are we able to solve? And what scale are we actually thinking about? I guess I should add universe or whatever, but all the way from quark to galaxy is like the scale. So what's really cool about this is you can now turn these into functional phrases. So you could say like an AI capable of curing aging by creating new chemicals that affect DNA. Okay, so we have a problem here. Creating new chemicals, that's like a net new thing, right? So that you're seeing this, verbs and nouns here. Maintaining a full city by monitoring and adjusting all public resources in real time. An AI capable of taking over a country by manufacturing a drone army and a new energy-based weapon. So this is like new science here. And an AI capable of faster than light travel by discovering completely new physics. So that's like a level above, right? So let's look at the different levels here. ASI 1, superior. An AI capable of making incremental improvements in multiple fields and managing up to city-size entities on its own. So here are the things that it has. Smarter and more capable than any human on many topics, able to move progress forward in multiple scientific fields, able to recommend novel solutions to many of our main problems, able to copy and surpass the creativity of many top artists, able to fully manage a large company or city itself. And keep in mind, copy and surpass some of the best artists. Now, what this really means is like in a superhuman way, right? So it's not just like better in one area. It's like, okay, it's Eminem, but it's way better than Eminem. It's Kendrick Lamar, but 5 times better, right? Same with these types of things. Novel solutions. Moving progress forward, which obviously no human has done, so they're doing it better. But it doesn't have these. It can't create net new physics or net new material science. It's unable to fundamentally improve itself by orders of magnitude. So next phase, dominant. Okay, first one was superior. Next one is dominant. This one has all of ASI 1, but it's also able to completely change how we see multiple fields, able to completely solve most of our current problems, able to fully manage a country by itself. So this is a huge jump over the first one. Able to fundamentally improve itself by orders of magnitude, but still can't create net new physics or run an entire planet. And then you have ASI 3, another massive jump, AI capable of creating net new physics, completely new materials, manipulation of near fundamental reality, or fundamental reality, if it's possible to do that, and can run an entire planet. And keep in mind, I might add ASI 4, if I have a clear picture of what that looks like. Hrishi, my buddy Rishi, mentioned, what about an AI that's smarter than all of humanity put together? And I was like, well, isn't that confusing knowledge with intelligence and reason? But I haven't heard back from him yet. But other things to consider here. So this one adds the ability to modify reality at a fundamental or near fundamental level, able to manage an entire planet simultaneously, and maybe its primary concerns become like sun expansion, which is going to eat up the Earth, or populating the galaxy and beyond, or the heat death of the universe, which is like escaping this reality. Yeah, or breaking out of the simulation. I should add that. So as a summary, AI terms are confusing. It's nice to have simple, practical versions. It's useful to crystallize your own definitions on paper, both for your own reference and to see if your definitions are consistent with each other. And I think these AI definitions work best when they're human-focused and practically worded, because it is very easy to try to be technical with these definitions, and you instantly open up like this giant mess the moment you go a level down in technicality. And what you'll find is if you get 20 AI experts in a room and a bunch of ML experts, they've been doing this 30 years, and you ask them their opinions, they don't agree. The textbooks don't agree. The experts don't agree. The moment you go a layer down, it's a giant mess. And that giant mess stops conversations from happening, because they end up they'll get 2 hours into a podcast and be like, oh, that's what you meant by AI? That's not what I mean by AI. And I'm like, okay, let's stop let's stop wasting 2 hours in a conversation because we're not talking about the same thing. Let's level up to an abstraction level where it's useful in a conversation. That's why it's called real world AI definitions.